Thank you again for joining us for Lunch with DASI. My name is Jim Byrne, and this is Weldment Design inside of SolidWorks. Whether you're new to SolidWorks or an old veteran, I'm going to walk you through some tips that will make you more efficient when working with weldment tools. I did have a couple of PowerPoint slides that I wanted to bring up, but I'm having a little bit of trouble with PowerPoint. I'm not going to need those slides. Basically, I was just going to walk through an agenda of what we'll be covering for the next hour. The agenda for this meeting is walk through creating a part from scratch and show a weldment cut list inside of a 2D drawing. We'll talk a little bit about all the aspects of using the weldment toolbar and how to create those features inside of SolidWorks and a little bit in drawings. And we'll be talking about creating additional profiles for weldments as well. I also want to talk about creating weldments using brown tubing, adding sheet metal to your weldments, things of that nature. We will talk probably separately about creating those weldment profiles now that I think of it. And also creating bills of materials with assembly documents, what that looks like when you have weldments inside of those assemblies, how that's displayed in the BLM. Maybe before I get started with the first component, which is creating a weldment, I'd like to get an idea of how long everyone has been using SolidWorks. And this is partly a question that's for fun, but also it helps me to find out where everyone is at. I'll show this one. It looks like, as far as the range is concerned, that it's right where I want to be as far as what I'm going to be showing today. Some of the functionality might be new to you, some of the tips. A lot of you who have been using weldments already, I will say that some of it may seem you've already seen this functionality, but again, I'm going to show as many tips as I can to make you more efficient using the weldment tools. In order to start from scratch, the first thing that I would like to do is create a weldment design. As I go through this, I think what you'll find is there's been some new functionality that's been added in 2011 as well. So if you are still on 2010, or you're thinking about whether you need to, or whether you want to move to 2011 right away, you may find some tools that will accelerate that. In fact, the very first tool that I'm going to bring up is new in 2011. When creating weldments, your weldment is going to be based on this skeleton, and that skeleton can be 2D sketches, it could be 3D sketches. The new functionality that I'm going to show is a grid. So I'm just going to create a 2D object and use the grid option in 2011. We'll choose this top plane to begin. And under the insert pull down and reference geometry is a new icon. It's called Grid System. And this does have a button, so if you use it a lot, then you can add it to your shortcut toolbar. Well, with the grid system, we start with our 2D sketch, and I'll draw that up as quick as I can. This will be the base of my skeleton for the weldment. You'll notice that as I'm drawing these line segments, it's giving me these labels for the grid. And I just have a couple more lines that I want to put in. We'll use a linear pattern in order to do that. And so again, you'll notice that the grid labels will update as you add more entities to this. Okay. I'm going to be periodically looking over at the questions, so in case you hear a moment of silence, I'm taking a look over there. I'll try to answer most of the questions at the end of this session, but if you have any, I'll be peeking over there just to see if there are any. Now, when we exit out of this sketch, we'll just double-click out here in space. In the Property Manager, there's our grid system. It will ask us how many layers do we want, how many levels, and there's a distance in between each one. And now I've got a default grid spacing, but we can use a different one or a different distance for each one of these. For example, I could type in 24 for this last one. And when I accept this, I get a new feature in my tree. Here are the levels over on my graphics view. And over in the Feature Manager, if I expand this, you'll notice the different levels are located over here. including a 3D sketch that we can right-click on to show, and this will give me these entities in between each of those corners on our 2D sketches. Now I'm going to go ahead and edit this one because my weldment doesn't have to be this large. I just have 2 layers on mine. We'll keep this as 18 inches apart. And those, if you do use the grid in 2011, these labels, they can be turned on or off just by using the view pull down inside of your view toolbar up here at the top. I'd like to start by going to the Weldment tab. If you don't have this turned on, then you can just simply right-click on one of these tabs in the Command Manager and turn it on this way. And I'll cover as many of these tools as I can. You'll notice that some of the tools, like for example Extruded Boss, the Extruded Cut, Hole Wizard, Chamfer, these are not different commands. They're actually the same button from the Feature tab, but they show them here in the Weldment tab as well. Same thing with the 3D sketch. It's not a different 3D sketch. It's still the same one. The Structural Member button, I'll walk through this. In the Property Manager, this gives you the ability to select from a number of standards, and these standards I have actually downloaded. You're not going to see this many by default, and I'll talk about how to get or gain access to these. Then we can choose the type. Again, I have several types that are not installed on the software by default, but I'm going to show that in just a few moments. And the size. By the way, all these sizes that you see, they're actually separate part files. They're library feature files. And then I can begin selecting these line segments, or arcs, by the way. You can use arcs as well. It doesn't have to be just lines, to generate our weldment. And I'll go through some of these features as we walk through here. For many of you, this is going to be something that you've already been through before, but bear with me as we walk through some more complicated items. SolidWorks has a corner treatment for these. If I zoom into this one, for example, I can change the corner treatment to an overlap or to a miter. Okay, and you can also do this for each individual corner by picking on this dot in that corner. I can change just that one corner to a different overlap. Okay, same thing over on this corner. Choose that point and change it. And now SolidWorks allows you to choose these entities in one group if they're either on the same plane or they're parallel to each other. So I can't select these line segments up here yet. I do need to pick on New Group. This was something that was new a few years ago. And then choose these entities. And there's a lot of benefit in doing this. There's a lot of automatic trimming that happens if you do this all in one feature. Now you can only choose one profile per feature. So if you do have a different size, it has to be, we have to accept this one and create another structural member feature. Okay, I'll create another group. Again, pick this button over here, and we'll fill in these as well. And again, you'll notice that it automatically trims that tube back. So we don't have to do we don't have to trim it after we've accepted this feature. But I will talk about the trim tool. Now when we accept this, we have the beginning of our weldment. Okay, notice that a couple of things happened. It created this structural member feature, and it contains all those solid bodies inside that feature, and a sketch that we can use to edit in case we want to make changes to the 2D profile that you can see right here. And you can modify that profile without affecting the original profile that it came from. Also, you'll notice that this weldment feature came in, and this does a few things. First, it changes your solid body folder to a cutless folder. And if I expand this, you'll notice here's all those solid bodies that it had generated. It also, under your configuration manager, adds a configuration. See, we've got default as machined and default as welded. So if you do have any machine features, you can go ahead and suppress those in this nested welded configuration. The third thing that it does is it changes the behavior of the way that you create other features in your design. For example, later when you see me create an extrusion, a boss extrude, it automatically turns off the merge result checkbox just because we have this weldment feature in here. Now back to that cut list, notice when I right click on this, we've got all these solid bodies in here. If we decide to create a cut list out of this for a 2D drawing, right click on that folder and you'll notice there's an option to update this. And it will take any similar items of mass and size and add them to cut list folders. So we can expand these. You'll see the solid bodies in there. It does this automatically. And you'll see the weldment cut list in the 2D drawing later. I think the next thing that I'd like to do is make a couple more tubes. And I'm going to do that on this face here. Start a new sketch. We'll walk through some of the other commands that are in the structural member feature. We'll add some dimensions too. Okay. Now I've got a couple of line segments right on that face. Again, under the Weldment tab, we'll create a structural member, and I'll just use the same profile size. Pick those two line segments, and notice that we've got some interference there. Well, inside the Property Manager tab, there's an option at the bottom to locate that profile. Click Locate Profile, and then we can choose any of the points that you have to locate this profile at the endpoint of that line segment. For example, I can pick this point here. And the more points that you have when you pick on Locate Profile, the better. See, I've got another point which is virtual sharp for that fillet. I could use that for a location too. So when you create these profiles, if you do have to make them, make sure you've got lots of points in there that you can use to locate these. Sometimes, though, you have to do more than just locate the profile using that command. For example, if I add another structural member, we'll do a rectangular tube this time and choose a different size. We'll go with 4x2. Choose our entity, and notice here our profile is rotated in the wrong direction, which is no problem. We can change the angle inside of the Feature Manager to a different angle, and I'll just hit Enter to accept that. So it rotates the whole thing. And now when I accept this, it's still not located exactly where I want it. In this case, I can't use the Locate Profile option because I don't have a point to select to place it where I need to. So sometimes you do need to edit the sketch that's inside of that feature. See, it's just a regular 2D profile that you can go ahead and edit. I'll get rid of one of these constraints and just pull this out a ways. And notice that you could either add sketch relationships, we can make these two coincident, or add a dimension between these two entities. We'll go with -1 here. So you could use sketch relationships, dimensions, just like you do any other 2D sketch to locate that, just in case you can't use the Locate Profile option. And now here I still have some interference between these tubes. There's a trim tool that we can use inside of the Weldment tab, Trim Extend, and I'll cover this a few times during this presentation. With Trim Extend, you've got a few options up here at the top to use a regular end trim, which we're going to do, or there's a miter trim and an overlap trim. Well, with the end trim, it's pretty simple. Select the body that you want to trim, and then select the face or body that you want to trim by. In our case, we could just use face. Actually, we could use both. If you do use bodies in this case, there is an option to use a coped trim or a simple cut between those two bodies. So you do have that option. Otherwise, just choose face. And notice that when you choose these faces, it shows a preview of what it's going to look like before you commit. And I can show this too. You can add a weld gap, a checkbox down here, and put an 1/8 inch gap in between these two. And you'll see new in 2011, you can create a weld bead between these components too, even though there is a gap. I think the other item that I want to show is just the creation of an extrusion inside of your weldments. Now, we can just pick this face and start a sketch, or you may have a number of profiles that you want to drag and drop into your weldments. We can do that too. See, I've got a weldment folder over here, and I just added one for the sake of this presentation. You could do a 2D sketch, or you could do a 3D model. I think I would recommend doing 2D sketches when you drag and drop these in, because the 3D model tends to leave the merge result checkbox on, even though we're creating a weldment. You could also drag and drop in parts if you want that are derived components. So if you change that part, it will change it in any other weldment that it's being used in. Well, I'm going to drag and drop in this sketch right over that face. And here in the Property Manager, we can first of all edit the sketch so that we can locate it. Let's see, we'll locate that right there. Maybe add a dimension. And also inside of this Property Manager, we can change the overall size of that foot. See, I've got length, width, hole diameter. If you want to know more about using the design library, it's probably not a bad idea. We probably won't have time to cover this during this presentation. And then once we have that sketch in there, we can go ahead and extrude it. Notice that, again, by default, the merge result checkbox is turned off, so it becomes its own body. And there are a number of other predefined features that you can use, for example, gussets and end caps. We'll take a look at a gusset. See, with the gussets, I'll start by picking a couple of faces. And you'll notice that it shows us a preview of it here. You've got the triangular form, and you also have a polygonal form profile that we can use. You can change the size of that gusset, the location of the gusset to make it centered, and whether it's extruded to one side or mid-plane. And then there's another button here to add a chamfer to the inside corner and apply a size. Oh, I got a question for the previous feature that I just put in, that foot. Do the properties carry through with the sketch to the cut list? That is a good question. My answer to that is yes and no. I may need to get back to you on this, because I have done it before, but it was I can't do it with that 2D sketch. I did try it in this case, and it did not work. So I'll have to get back to you on the answer to that question. I believe if you drag and drop in a derived component, the properties come over, but not necessarily a 2D sketch, which I did here. Okay, back to the gusset. My suggestion would be to turn on this Keep Visible push pin, so that when you accept this, you can go ahead and pick on a couple other locations for the same gusset. You don't have to enter in those properties in again. And then just cancel out when you're done. And now you'll notice that it did create these bodies inside of our cut list folder. When we right click, again, you have the ability to update this, and it will create folders, cut list folders for those individual items. Well, I'm going to go ahead and use our mirror tool to place these bodies, not features. Make sure that you do pick on bodies to mirror, not features to mirror. Hang on a second. Okay, there we go. And I'll do the same thing in the other direction. Choose our plane and mirror these bodies to the other side. So I got a few too many. Didn't need that one. Okay. And again, we've got these, even when you mirror or pattern those bodies, they will still be placed in those cut list items when we update this. Okay, so I still get the same number of cut list items. And when you highlight them, you can see that they highlight over in the graphics view too. By the way, you can rename these bodies or these folders. For example, this is my gusset. It's not necessary, but when you see this in the properties of your cut list, then it'll be easier to tell which is which. There's another thing that, well, actually, let me show this right here. I'm going to place another sketch on this face right here for just an angle iron. And sometimes you want to, I could have placed this sketch in the original profile when we created the grid, but every once in a while your lines are going to be defined by existing geometry. So it becomes easier to do this now rather than earlier. So just something to keep in mind. And it gives me another profile that we can bring in. Again, go back to the Weldments tab, add a structural member. Oh, let's see. Let's go with an angle. Again, sometimes these profiles might not be rotated the way you want them. You can change the angle right there in the Property Manager. Speaking of rotating, I may show you something that a few of you have come across before, I'm sure. Let's roll back to the sketch that we had created. We'll use the 3D sketch option to make an additional line segment in here. Okay, that's good enough. We'll add a line there and just put in another tube. See, if I guess it doesn't matter what I choose here, but I'll go with another square tube. If I look normal to this, it's rotated on me. There's a couple of options there. You can either change the angle. I could make that 45, and I believe it will work here. Or there's the alignment option as well. If you pick on this selection box, then we can pick on an edge or a line segment. I suppose I would suggest a line segment since these edges might change to line that profile up. Okay. And then, of course, if we accept this one, it was created as a separate feature, so we need to use the trim tool there. And I'm going to save myself some time and just not do that. Get rid of that. End caps. Throw in a couple of end caps here. With end caps, it's a feature inside of your Weldment toolbar. Notice I can go ahead and select these faces, and we'll do them all. I would like to do them all because it will keep the length consistent for those tubes. See, notice that we've got options to make that a recess that in a bit. You can go outward or inward, so it's flush with this other tube, and we can add chamfers there too. So now when I accept this, that means this tube is going to be a little bit shorter, and we're still going to get an accurate length for that tube when we create a cut list. How about weld beads? Weld beads, this is going to be something that's new in 2011. I'm going to go ahead and update this cut list here so we get one for the end caps. The old fillet bead command is gone in 2011. It's been replaced by the weld bead tool, and it's much better because it works in more areas than 2010. First of all, when you choose faces, it shows you a preview of where the weld bead is going to go. And in the property manager, you can choose the size. We could make this use tangent propagation, all around as an option. And there's even an option to define a weld symbol in here so that you can specify all the information you need for that weld when you create the 2D drawing. And there's some nice ways of selecting these too. I can go ahead and pick more locations for this. I have a smart selection tool, a smart weld selection tool, where we can drag across those faces. And it's kind of like using the trim tool in a 2D sketch. So it's not going to save you a ton of time, but it's just fun to be able to drag your cursor over these in order to get that to work. Okay, we'll do the same thing over here. Grab a couple more locations. And when you accept these, notice that you get a symbol for the weld bead too. But here's the big thing. See, in 2010, you would get this solid body that shows up over in the cut list. And it's not, I guess it wasn't a huge problem, but all these solid bodies would show up in the tree that you really didn't want to see there. And it doesn't do that anymore. And I'll show you where they go, but let me create another weld bead here first. The different types of weld beads are still available. For example, if we want to add a bead on both sides of the gusset, there's a from to option if we want to make the weld bead a different length. Intermittent weld, so you could change the weld length and gap. And you can also stagger them. Check that box to stagger it. And just keep on picking other locations. I want one right there. See, we can place these anywhere right there. By the way, if you're using this smart weld selection, then when you start dragging, make sure you start dragging on the face that's not selected yet. Otherwise, it takes a couple of tries to do it. So just keep that in mind. I want to start dragging here. And I'll just do that side. So what happens to, well, there's my symbol, first of all. And look at that. I don't get all those solid bodies from the intermittent weld. Now, you'll notice that a new folder shows up inside of the feature manager, your weld folder. See, these are the two that I just added. When you right-click on those, you get a bunch of information that you can apply to this weld. See, you've got weld material. I'll fill in a couple of these. And the weld process. There's unit mass per unit, weld mass per unit length, cost per unit mass, time per unit length, number of weld passes, and then there's some automated information over here. And all this information can be used inside of your table in the 2D drawing. Just for the sake of putting in different properties, we'll do that there too. Now, before we create the 2D drawing, oh, can you do gussets across? The question about gussets across tube radii, I haven't seen that as a new item in 2011, so I'm assuming it's still the same. But I'll get back to you on that one as well. Before we create the 2D drawing, when we right-click on any of these folders in the cut list and go to Properties, this was something that was new, I believe, in 2010, at least the interface. Notice that we have 3 tabs up here. The first tab allows you to walk through and see the properties for each of these items. So you notice I renamed that gusset folder. Again, that's not something that you have to do, but it might help. Well, when you pick on these you'll see what properties are already in there. See, for the gusset, I don't have a description in there yet. I don't know why that is, but for some reason SolidWorks doesn't make an automated description for that. And I'm not going to make these real detailed. I'm just going to put in something that's very generic. However, for the foot, this one I might want to put in a description for the size. And you might decide that you want to use the actual dimensions from the model. See, if while I'm in here, I added a description. I want that to be the length by the width by the thickness. And I'm just picking those dimensions and placing an X in between each one. So now this value is based on the actual dimensions instead of something I just typed in. Oh, I forgot. And if you go back to properties, you'll see that the property summary allows you to look at all the descriptions for every cut list item or all the lengths. Or if I go to the cut list table, this is a preview of what your table is going to look like. And there's, by the way, a checkbox here in case you want to exclude any of those items from the cut list in the drawing. All right, well, with that said, let's create a drawing. I'll bring in a couple of views. Let's see, we'll go with a front, maybe a top. And I think I'll drag and drop in a current model view so you can see how this works. If I drag and drop in a current model view, or, well, almost any view for that matter, then there's an option up here in your view toolbar to rotate that view. This is not necessarily a new thing in 2011, but the new part of it is it's easier to do, and I can accept that view if I like it without having to make that view, or I could click between these other ones that are available too, the standard views. Let's turn off our sketches. And maybe you don't like the tangent edges on your tubes, so we can go ahead and turn off the tangent edges for those. Maybe show the hidden lines for the tubes and the gussets. And let's go ahead and do the cut list. Now make sure that you had updated the cut list folder that's in the part before you do this, otherwise you won't get any items. Weldment cut list, we'll go ahead and accept the default table. And we can, some of you might not know this, but you can drag and drop these around to change the size, especially if some of these rows get too large, you can drag and drop that around. See, all the descriptions that you put in those folders will show up in here. Again, this one is based on the size of that foot. For the balloons, we'll use the auto balloon function, or you could use the regular balloon function if you'd rather use that. And we can place all our balloons up here at the top. And you may also want to show the quantity on these too. This is fairly new. You can. This was in the software a couple of years ago. We can show all the totals, the quantities to whatever side of the balloon you want. And I may move those balloons around a little bit, but we'll just leave it as is for now. And you may want to create also detailed drawings of some of these individual bodies. Here's how we do that. If you choose a view and go to Insert Drawing View, you'll find a Relative to Model option. Relative to Model will open up the model in its own window, and then make sure you use Selected Bodies for this. Choose the body that you want a detail of, and then you can choose faces to line up that view. Once you've chose a couple of faces, it will place you back into that 2D drawing, and we'll get a detail of just the foot or any of those bodies that you had in that weldment. Let's change the scale of this one. Then of course you can project other views off from that one. And add some dimensions. In fact, I think I will add some dimensions because I want you to see a change. Well, maybe we'll throw the diameter in there too. Now, if I do want to go back over to my part, I'm going to make a change to that foot. And I could change it just by clicking on these dimensions, or you could go back to the library feature too, because remember that library feature still has those dimensions in here. I'll just change them directly from the model. Let's see, we'll make this 6. Change that to 2. So I'm modifying the size of that foot. Now, when I go back over to my 2D drawing, a couple of things changed. Of course, the overall view of my model that I have here. Notice that the description updated too, and the detailed drawing of the one solid body. So everything stays up to date. Especially if you're using the dimensions that came from the model for these descriptions. I got a question as an enhancement. Why can't the relative view default to the selected body option? I guess why can't you? Why do you have to pick selected body? I think that was actually an enhancement itself. Because in the past it would automatically go to a solid body, and you couldn't use it otherwise. Yeah, I mean, I'm agreeing with you there. I think that almost all the time I want it to default to selected body, so that would be a good enhancement to add. Oh, and one other thing. If I create a table, here's the weld table for the weld beads that we added. So any property that you saw in the model can be used in these columns. For example, maybe instead of the weld material, we want to use weld process. So all those are available in there. And these tables, just like any other one, can be saved off if you like the column headings that you have up here. The item numbers cannot show inside of the views yet, but they're there now, so I'm assuming that's something that they're working on. You can import the weld symbols and you can import those weld symbols into the drawing using model items, but we just can't use item number yet. All right, I'm going to close this one. I have another poll question that I'd like to bring up. This one has a little bit to do with the functionality that I'm showing here. I'd like to know what release of SolidWorks you're using right now, because I am showing some 2011 stuff, some 2010, some 2009 enhancements. If you're on 2007 or 08, a lot of the functionality might be a bit different. There have been some enhancements, some significant ones, just to give everyone an idea of what everyone's using in the webinar today. I might not get to everything that I want to today, but I think I would like to jump into real quick, how do you find and create new weldment profiles? Inside of your options under file locations, there's in this pull down there, you'll find weldment profiles and weldment cut list tables, by the way, too. The weldment profiles, you want to make sure that all of your profiles are pointing to this folder. It's a good idea that everyone in your company or organization is pointing to the same folder for this. Now let me show you mine a second. Okay. I have a folder for Weldment profiles, and these are all the standards that you can download for SolidWorks. And you'll notice that under each of those is the type of profile. And then every profile that you use is a separate file. It's a library feature file. Now, if you do want additional profiles that are not included on the install, be sure that you go to the Design Library tab under SolidWorks Content, and you'll find a Weldment folder there. Just Control-Select on any of these standards that you see, and download the zip file that contains all the profiles, and be sure that you place them in that directory that you specify under file locations. Now, if the profiles that you need are not there, you can always make your own. They're just 2D sketches. Or if, for example, you want to search for one, you can go online and find a 2D profile that you can import into SolidWorks. You could use the search tool up here. Oop, I don't want to search help. Search files and models. And search 3D Content Central for profiles depending on what you're looking for. And so when you find the one that you need, you can simply drag and drop that right into SolidWorks. Now, I'm not going to download this one. I think I'm just going to open an existing one. Actually, I did download this one, but I don't want to download it now. All we need is the sketch. So I'm going to delete the extrusion, and I'll go ahead and look normal to that. The default location of your tube is going to be where the origin is on that sketch. And so you could change that if you want to move the sketch around, if you want to edit it. Otherwise, when you're ready to create a Weldment profile out of this, pick that sketch, make sure you select it, and in the Design Library tab, we can add this to our library. Now, one of the things I would suggest is to add a file location, which is your Weldment profile location. It makes it a lot easier. There we go. Okay, so now I've got a location for my Weldment profiles. Again, choose that sketch. Oop. Add to library. Pick that button over there. Okay. And choose where you want to place it. So here I have a folder that I already created for this. And there's a couple things you want to do. Make sure that your file name is put in. I'll just use the same thing for description. Make sure the file type is a library feature part. Don't leave it as a block. Okay, library feature part, and accept that. You'll notice that this little L shows up over that sketch. So now we'll go ahead and close this. I'll create a simple 3D sketch. When you're creating 3D sketches, many of you know that you can use your tab key to draw in different directions. See, if I click tab, I can draw in my YZ instead of XY direction. Just click tab. You can change that. Or you can double click on planes to draw on those. Now we'll make these all equal. Let's make that a little bigger. So now when I add a new structural member using my new folder in size, we can choose those. I'll use a new group for this one right here since it's not parallel. By the way, there's additional trim options that are available too for these corners. You can do some pretty interesting trims. You can kind of see my preview now. When I right-click on this, or I'm sorry, left-click on this corner, there you can change the trim order when you've got conditions such as this. I don't think anyone would do this with 80/20, or I don't think so. But you know, maybe with round tubing or something of that nature. I do want to mention round tubing real quick with sheet metal. We'll use the grid system again just to save ourselves some time. Remember, this is new in 2011. Okay, exit out of that sketch. We'll go with 3 layers for this one. And we can create another 3D sketch for some additional features that we want to add. This is actually going to be a bale feeder. Oops, wrong way. And we'll add maybe a 6-inch fillet there and there. Okay, good enough. So there's our profiles that we want to use. Again, we'll go to structural member in weldments, and I want to use round tubing here. Choose our size. Any size will be fine. And now, if you do need to make new groups, you can do that from the graphics view. Right-click and create a new group. That way you don't have to go to the feature manager every time. Just be careful when you right-click, because you don't want to right-click right there, for example. It's going to accept the feature. So move your cursor and then right-click, create a new group. And by doing this all in one feature, again, it automatically trims this for us. And I want to pattern those, so we'll create an axis in this case. I don't have an axis to choose. And then we can pattern this. Oh, again, make sure that you're patterning bodies and not features, bodies to pattern. Now, if we want to create sheet metal in here, we can do that too. I'm going to go ahead and start a new sketch for a sheet metal component, and we'll just offset this outer edge or outer line segment to a small distance. And under my sheet metal tab, we'll create a flange to a depth. So I created a sheet metal part within this weldment, which is nice because then if I right-click on that, I can hit flatten to show the flattened state of that sheet metal part and click on that edge and find out what the length of that sheet metal part is going to be. In fact, I can also right-click on it to export the DXF right from here without making a drawing. So we could do as many sheet metal parts as we want inside of this model. And if I make a 2D drawing of this, let's see, let's save this. When excuse me, I didn't make sure you do this. I forget this all the time. See, there's all my solid bodies. Right-click to update that for your weldment, so you get the cut list items. Oh, and by the way, keep in mind that if you want to exclude the sheet metal part, then we can check the box to exclude that from the cut list. Notice, by the way, all of these properties that we get for that sheet metal part, like the bounding box length, there's the length of my flat sheet metal part, and the height. So we get a lot of this other information for that sheet metal part too. All right. So in the drawing, here's my cut list. And we get the lengths of all those tubes. In fact, you may want to know this too, that if I insert a row below, that this cell can be an equation See, there's the little sigma symbol there for an equation, and link it to the sum of these. So it's just like Excel. There we have a total length for all the tubes. Now, I've had a few issues with this, so be a little leery of this value when I update the lengths of those tubes. Sometimes that has not always updated for me, so be careful with that. Another way to know all the total lengths of your tubes is to create a drawing of the assembly. This might be the last thing that I can show. See, with this assembly document, I've got several weldment components. And there may even be other parts in there that are not weldments. And to save myself time, I won't make a drawing of this. I'll just go straight to BOM in an assembly document. This, by the way, was new in 2010. Create a BOM in an assembly. Now, if I go with just components for this, then my BOM looks something like this. These are all the parts that I have in this assembly. Well, if I change this from parts only to indented, then I get the individual items and that weldment cut list and the lengths for those. Oh, I'm sorry, this is the total length. So if I go back here again and change this to detailed list, it gives me all the individual cut list items. And then in this case, I might need to insert a column, it looks like. Insert 1, 2, we'll go to the left. And change this property to length. Okay, so this is the length of each individual cut list item. Again, if I turn off detailed cut list in an assembly, this gives me the total length for each type or each size. If I'd like to post just a couple other polls. Well, one really. I'm curious: if you're creating weldments, are you using the weldments tools, or are you making them as assembly documents? Some of you may not be using weldments at all. You might just be here to listen in on one of our webinars. I'll post this one too. And well, several of you are using assembly documents for your weldments, and that could be for a number of reasons. It may be because some of the functionality you've seen today you might not have yet, or maybe you've got some special ways of creating those weldments that only work in assembly documents. Well, that concludes this Lunch with DASI webcast. Thanks for joining us. Feel free to visit our website for future webcasts and tips and tricks in SolidWorks. In fact, there are a few more webcasts coming up in the future if you're interested in how to deal with data management or technical documentation. I'm also going to be doing one on using the design validation tools that come with every seat of SolidWorks. So keep an eye on those. And if you do have any other questions, feel free to stick around for a few minutes, and I'll do my best to answer them. Otherwise, have a great day and enjoy your weekend.